have that horizontal and vertical aspect. Okay. So now I'm going to scroll over to our new notes for today. Today we're going to start on linear functions, graphs of line. And when I made these copies, I did not number the pages, but your stuff for next week will be numbered. I'm so sorry. I hate it that they're not numbered. What do you got for me? Yep, I'm right there. There you go. So what suburb of Chicago did you grow up in? Okay. Nice. We'll have to talk later. So I'm from Chicagoland, but I actually spent the last like 20 years in Indianapolis. So we kind of shared some of the same space, but that's pretty cool. All right, here we go. So were you good with that, Hayden? I didn't even ask. Okay. So today we're talking about graphing linear functions. So notice that it says the graph of the linear function is shown below, but really I moved it over to the right. So it says, write the equation of this line in the form y equals mx plus b. So remember, whenever we see this form and we're looking at an equation, we are trying to find the slope and we're trying to find the y-intercept. So I'm actually going to just look at the graph and see if we can put a mark where the y-intercept is, and then see if we can't count some slope together. Okay. So I'm going to move over to my graph, and I want to find out where the graph crosses the y-axis. So my graph crosses the y-axis right here. What is that number? 1. So b equals 1. And I write that down because that just helps me think about it. Now I need to count my slope. And remember that your slope is your change in your y over your change in your x. And I'm going to kind of make it nice and big so we can do some counting. Change in y, so that's your vertical, over your change in x. So I always kind of try to draw a little triangle that helps me think about my slope. And then I just count it. How much do so I say to myself, am I going to go up to get to the next point? Am I going down? I'm going up. So that means my slope is positive. 1, 2, 3, 4, 5, 6. So I go up 6. And then I run to the right. 1, 2, 3. So my slope is 6 over 3, which is the same thing as what? Same thing as 2, or 2 over 1. Absolutely. And now I know that I could have counted the slope right here. 1, 2 over 1. I just tried to make it nice and big for you. Okay. So what is the equation to the line that's graphed at the right? So replace the variable m. So y equals, what's my slope? And we reduced it to what? 2. Yep. Y equals 2 times x plus, what's my y-intercept? Sebastian just said it. 1. So that's the equation that you're writing. This equation right here represents the graph at the right. Okay. So the second part of this says, well, what must the slope of the line that's perpendicular to the line that's shown be? What do we know about? So let's talk about perpendicular lines. Yesterday I asked you about parallel lines. Today let's talk about perpendicular lines. So perp lines, I abbreviate as much as possible, sorry. And the symbol for perpendicular lines is an upside down capital T. It's really what it looks like. It's an upside down capital T. So what do you know about perpendicular lines? Anybody? Tell me things that you know about perpendicular lines. Kind of. It's almost opposite. That's one of the words. What do perpendicular lines do? They intersect. What shape do they make when they intersect? Like when they intersect, what do they make? An L. Okay. What else? What do you know about this point right here where my elbow and my hand meet? They make a right angle. Yeah. So perpendicular lines make a right angle or meet at 90 degrees because that's what a right angle is. Okay. So we said we think that they might be opposites, right? We think that they might be opposites. So violet, right? Okay. So let's see. Let's talk about the slope of perpendicular lines. The slope of perpendicular lines, well, they are opposite. Opposite means that I change the what? When I say the word opposite, that means what? If it's positive, I make it, or if it's negative, I make it. Okay. So the word opposite means that I change the sign. Okay. And then they're also reciprocals. What does that word mean? Yeah. If you think, if you were to think of the slope as a fraction, like 6/3, what's the reciprocal of that? Flip it. Yeah, you flip it. So instead of 6/3, it's 3/6. We reduced our slope to 2. So if I write it as 2/1, the reciprocal would be what? 1/2. It means flip. So the slope of our perpendicular line has to be the opposite. Well, what's the opposite of a positive? A negative. And the flip of 2/1 is 1/2. Good job, you guys. That's awesome. So that's what the slope of a perpendicular line has to be. Opposite reciprocal. This idea right here is really important. Slope of perpendicular lines, opposite reciprocal. If you want to box that in, put a highlighter on it, whatever, that's kind of like the key idea of perpendicular lines. Okay. So the next thing it says that we have to do is we have to draw a perpendicular line to the one that's already shown on the graph, and it has to pass through the point 1, 3. So I'm going to tell you how we're going to do this. We are flipping the other way. Yes, we're going to start at the point 1, 3. That's going to be where we start. And then from there, we're going to count our slope, which is -1/2. That means that we go down. Negative tells me that I have to go what? Down. So I'm going to go down 1 and to the right 2. That's really what that means, okay? So I want you guys to go to the graph and start at the point 1, 3. Go to your graph and find the ordered pair 1, 3. And from that point, I want you to count your slope. I don't want to do it until you guys are ready. Who's still writing that down? Who needs more time? All right, I'm going to go to the graph, okay? So I have to begin at the point 1, 3. So my ordered pair 1, 3 is this point right here. Over 1, up 3. And then from there, it says my slope is -1/2. So I have to go down 1 and to the right, 1, 2. I'm going to put a point there. Then I'm going to do it again. Down 1 to the right, 1, 2. And I'm going to connect these points with a line. And I'm even going to do this. I'm going to put this symbol right here. What does this symbol tell you? The arrow means that it keeps going, but what does that little red symbol that I drew in the corner mean? It's a right angle. Yeah. So whenever you see that symbol, you know that those two lines are perpendicular. That's how we tell whoever is looking at our graph that those two lines are perpendicular. We draw that little right angle in there. Okay. Does that make sense? Yeah. Okay. Raise your hand if you need me to keep that up there for a minute. Okay. I'm going to move on. So it says, write the equation of the line that you just drew in point slope form. Well, remember, point slope form needs an ordered pair, x sub 1, y sub 1, and then it needs the slope. Point slope form looks like this, y minus, who can tell me from yesterday what point slope form is? It was on the front page of our notes. Look at the front page of your notes. Not you. Front page of your notes. What's point slope form? Go ahead, Hayden. What is the form of the equation point slope? It's in the box at the front. What do you got, Sebastian? And you see that? I don't know if you can see it. There's those y's and x's have a little 1 next to them. We call that x sub 1, y sub 1. So remember that your slope comes from the point or the graph, like it tells you what your slope is. And then that y sub 1, x sub 1 comes from the ordered pair. So I think that we said our slope was negative 1/2. And the point that we started at was the ordered pair 1, 3. Correct? So if the ordered pair was 1, 3, Caden, tell me the value of, I'm going to start writing my equation, y minus, what am I putting in for y sub 1? Three, good job. Y minus 3 equals, Jansen, what am I putting in my equation for m? What is the value of my slope? Say again. Yeah, negative 1/2. I don't know why that picked up the eraser. Negative 1/2. Parenthesis, we say times the quantity, x minus, Justice, can you tell me what value am I plugging in for x sub 1? What's the x value in my ordered pair? Yeah, 1. Good job. This is the equation in point slope form. Okay. Are we good with that? Okay. Question E says, hey, if this graph were to go on forever, basically, lines go on forever, right? So it says, does the ordered pair 30, negative 15 fit on that graph? Say again? No, it's not undefined. You mean because it goes on forever? No, all lines go on forever. They're undefined as if it's a vertical line. Okay. So how am I going to figure out if this ordered pair lies on this line? I'm going to write that down. Does 30, negative 15 lie on y minus 3, because that's the line we're talking about, equals negative 1/2 times x minus 1. How could I figure that out? Should I graph it in decimals and see if the point 30, negative 15 is on there? I could do that. What else could I do? It's already in point slope form. What does 30, negative 15 tell me? What does the 30 represent? A what value? It represents an x value. Sorry. I'm so sorry. 30 represents an X value. Okay. What does the negative 15 represent? A Y value. Okay. So notice that we can take this negative 15 and put it right here where Y is. And we can take this 30 and put it right here where the X is. And we can see if we get a true statement, right? We're just going to plug it in. So let's see. Negative 15 minus 3 equals negative 1/2 times 30 minus 1. All right. So what is negative 15 and negative 3? Remember yesterday, when I look at integers, I just kind of circle them and say to myself, are the signs the same or are they different? They're the same. So if the signs are the same, I'm just going to add those two numbers together and keep the sign. Negative 15 and negative 3, negative 18. Good job. Does negative 18 equal, what's 30 minus 1? 29. What's half of 29? Just give it to me. You guys, half of 30 is what? 15. So half of 29 is 14.5. So this says that negative 18 equals negative 14.5. Is that true? Does negative 18 equal negative 14.5? No, that's not true. Like you thought I meant, did we do the math correct? Well, yeah, we did the math correct, but do we get a true statement? No, this is false. Right? So if it's false, that means that this point is not on the line. This point is not on the line. That's what that means. That point does not lie on our line. Okay. One thing that I love about math is that you can solve problems multiple ways. One thing that I hate about math is often we try to trick you with it, meaning like you know what I'm asking you, but we give you a question like this and you get a false statement and you automatically think that you did something wrong, right? Typically, is that true or false? If you get something like this and you're like, oh, it doesn't work, I must have made a mistake. And so I want to show you questions like this so that you know, I want you to believe in your math skill and know that they're trying to trick you. And they want you to think about what false means. What happens when you get a statement that says something is equal to something else and it really isn't. Okay. All right, let's move on. Okay. So for each of the equations below, write in the form y equals mx plus b if you need to. And then identify the slope and the y-intercept and graph it on the grid. So let's look at example A. Can you tell me the slope and the y-intercept? Anyone? The slope is what? Who said that? Sebastian? No. Oh, Noah? Noah, that's awesome, except that I don't want you to put x as part of your slope. Remember that x is a variable, right? The slope is just the number attached to the variable. Okay? What is your y-intercept? What do you got? Cameron. -3. Good job. Okay. So we'll graph that in a minute and we're going to label it line A. Let's do line B really fast. Someone tell me what the slope of line B is. Tricky one. -1. Good job. And what's the y-intercept of line B? 6. Okay. So when you graph these, remember B is your y-intercept. This is where you begin. You begin at B and then you count your slope. And your slope is 2 over 1. And because they're both positive, that means that I go up 2 and to the right 1. So I want to do that one together. So I'm going to begin at -3 on the y-axis. So -1, 2, 3. This is where I begin. And then my slope is 2 over 1. That means that from this point, I go up 2 over 1. I'm going to do that again. Up 2 over 1, up 2 over 1. I'm going to do it so I have enough points that I can draw a nice straight line. Do you guys feel really comfortable with graphing y equals mx plus b? Or do you feel like you need more practice with it? Raise your hand if you feel really comfortable with it. Okay. I would say that probably graphing is going to be one of the things that we really focus quite a bit on, because graphing is everywhere. Graphing is in math, it's in science, it's in history. So I want you to be comfortable looking at graphs. Okay. So line B says I begin where? Yeah, I begin at 6 on the y-axis. 1, 2, 3, 4, 5, 6. And then I have to count my slope. And it's -1. I always write my fraction or my slope as a fraction. So -1 over 1. This negative on top means that I'm going to go down 1, and we always run to the right. So I start at 6, and from there I go down 1 to the right 1. And I'm just going to repeat that pattern. Down 1 to the right 1, down 1 to the right 1. I'm going to give myself some points, and I'm going to draw that line, and I'm going to label that as line B. I'm going to label that as line B. Okay. Let's go over to example C. Example C. I did not pass out filled out notes. I'll grab them in a second. Okay. Sorry. Example C. That's weird. So yesterday, pick your head up so I know you're paying attention. Yesterday I talked about standard form. Is that equation written in standard form? It is. Do you guys remember something that we learned? We learned a way to graph when an equation is written in standard form, and I called it the cover-up method. You guys remember that? Yeah? Do you remember what that looks like when I cover it up? What do we use the cover-up method for? What's that going to give us? When I cover it up, it gives us the graphs, what? Yeah, it gives us the intercepts. It gives us the intercepts of the functions, okay? So let's find the x-intercept. I'm going to find, thank you, ma'am. I'm going to find the x-intercept. So if I want to find the x-intercept, I just cover up the y term. What equation do I have? Good job, Justice. 2x equals -15. Divide both sides by 2. So x equals, what's 15 divided by 2? You can use your calculator. Yeah, so -7.5. That means that this graph C, is going to cross the x-axis at -7.5. So my graph is at -5, 6, -7.5. I'm going to put that point right there. Right in between -7 and 8. Do you guys see where I drew that point on my graph? Now let's find the y-intercept. So if I want to find the y-intercept, I just cover up the x term. Now what equation do I have? Be careful. Good job, Hayden. Negative. Don't forget that negative. Sometimes we tend to drop that. -5y equals -15. Divide both sides by -5. Y equals 3. That means that my graph crosses the y-axis at +3. 1, 2, 3. So I've highlighted the two intercepts. Now I'm going to connect those 2 points with a nice straight line, and I'm going to label it C. Okay. So let's see. Our first 2 equations were given to us in slope-intercept form. Our second equation was, or our third equation was given to us in standard form. What form is example D? What form is this? the one I had you guys look up. Yeah, this is in point slope form. So that means that this number right here is my what? What is that fraction in front of the parenthesis? That's my slope. M equals 2/3. I'm going to write out the form. Y minus Y1 equals M times X minus X1. So I need the point. I need to find the ordered pair. How am I going to do that? Well, my ordered pair are these two numbers. So what is my ordered pair? So what's the X value? So X is right here. And it's supposed to be X minus. It's set up as X minus some number. So how did that turn into a plus? Because it was minus a negative. So this is really X minus -6. So that means that my X coordinate is -6. My Y coordinate is what? 4. So I'm going to start at this point, begin at the point -6, 4, and then count your slope 2/3, up 2/3 from that point. So let's do that. Let's start at the point -6, +4. 1, 2. I'm at -6 and I'm going to go up +4. That's this point right here. So I went to -6, up 4, and then my slope is 2/3. So from here, I'm going to go up 1, 2, over to the right, 1, 2, 3. I'm going to do it one more time. Up 1, 2, to the right, 1, 2, 3. And I'm going to label this line, line D. Okay, so here's what we're going to do. I'm going to freeze that so we can all get caught up on that.